Dear students, Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to a new lesson for grade 8 in geometry, and the lesson title is Triangle Inequality. First, here are the learning outcomes of this lesson. By the end of the lesson, you should be able to recall the inequality of angles in a triangle, recall the inequality of sides in a triangle, understand the triangle inequality, apply the triangle inequality on examples. First, let's recall the inequality of angles in a triangle. The rule says, in a triangle, if two sides have unequal lengths, the longer is opposite to the angle of the greater measure. For example, here on triangle ABC, if AB is greater than AC, the length of the side AB is greater than the length of the side AC. We have angle C opposite to the side AB, and also angle B is opposite to the side AC. Then we can say that measure of angle C is greater than measure of angle B. Now if we apply this piece of information on this example, if BC is greater than AC, so which angle is greater than which angle? Exactly. Excellent. Then measure of angle A will be greater than measure of angle B. Moving on to the inequality of sides in a triangle. The rule says, in a triangle, if two angles are unequal in measure, then the greater angle in measure is opposite to a side greater in length than the opposite to the other angle. This is the contrary or the opposite case of the rule of angles. Here we mention the angles that we can conclude the sides. Here we have measure of angle C is greater than measure of angle B. Then angle C is opposite to side AB, and also angle B is opposite to side AC. Therefore, we can say that AB is greater than AC. Now for the rule of the triangle inequality. In any triangle, the sum of the lengths of any two sides is greater than the length of the third side. This is a general rule for any triangle. The sum of any two sides should be greater than the third side. This is a hint on how to solve the exercises related to the triangle inequality. To check the possibility of drawing a triangle if the length of its sides are given, we should sum the smaller two lengths, then we compare the result of the third side. If the sum is smaller than or equal to the third length, then it will be impossible to draw this triangle. But if the sum is greater than the third length, then it is possible to draw the triangle. Now let's apply this rule on this exercise. Question: is it possible to draw a triangle whose side lengths are as follows? Give reasons. In the first example, we have three sides, 10, 6, and 4. As the hint says, we should sum the two small sides and compare it to the third side. Then 6 plus 4 equals 10, and when the result is compared to the third side, they are equal. So the answer is no, it isn't possible, because the sum of lengths of the two small sides isn't greater than the length of the third side. Moving on to the next example. We have here three sides, 5, 7, and 8. Now we will sum up the two small sides, 5 and 7, and compare it to the third side, 8. Here we have 5 plus 7 equals 12, and 12 is greater than 8. So the answer is yes, it is possible, because the sum of the lengths of the two small sides is greater than the length of the third side. Find the interval to which the length of the third side of a triangle belongs in each of the following triangles if the length of the other two sides are. First example, 6 and 9 cm. In this example, he wants to know the interval of the length of the third side. If the two sides are 6 and 9 centimeters, what is the length of the third side? We have a rule to calculate the interval of the length of the third side. We need to know the difference of the two sides and the sum of the two sides. As easy as it is, we will subtract these two numbers and we will add these two numbers and put them in open intervals, and the example is done. Here we have 9 difference 6 equals 3. 9 plus 6 equals 15. Therefore, the length of the third side belongs to open interval 3 and 15 open intervals. Just remember here that the two intervals are always open. Moving on to the second example, we here have the two sides 2.9 and 3.2 centimeter. Now it's easy to apply this rule. We will have the difference between the two numbers and the sum of the two numbers, and we will put them in open intervals. Therefore, the length of the third side belongs to open interval 0.3 or 0.3 and open interval 6.1. The final step for us today is to summarize our lesson objectives. Today we recall the inequality of angles in a triangle. We recall the inequality of sides in a triangle. We understand the triangle inequality, and we apply the triangle inequality on examples. By the end of our lesson today, I thank you all for watching the video and wish to see you all safe and sound, and see you in another videos inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.